My name is Wim Doge and I'm in charge of the sales at Stevo Electric. Today I will be showing you one of our latest products, the BCD, the Breaker Control Drive. We have developed this product because we encountered on numerous occasions that the transit agencies did not have the capabilities to close and open their breakers easily. So when we went down on site to give a demonstration of our primary injection kit, we noticed that the right device was failing to open and close the breakers. That's why we developed the BCD. The BCD has two models, the BCD4000 with a maximum power of 4000 watt and a BCD6000 which can generate 6000 watt of power. That's for the real heavy breakers. Let's zoom in to the BCD front panel and explain to you the different functions. Here is the power outlet and you can plug it into a standard 230 volts power supply, or for the US 120 volts AC power supply. It contains two power supply units, a power supply of 24 volts and an adjustable power supply which ranges between 24 and 110 volts DC. This is easily adjustable by turning this knob. As you can see, it's now at 100 volts and it's adjusted to 110 this time. 110 volts is very often used for circuit breakers, but you have circuit breakers which operate at 48, at 60 volts, 72 volts, 90 volts. This is a very versatile unit, so it should work with any type of breaker. So the two power supplies, 24 volts, 110 volts DC. Here on this side we see the contacts, the outputs for connecting the coil of the breaker. We support electronic holding type of breakers and magnetic type holding breakers. Actually, the device was developed in order to support any type of circuit breaker. Here are some specific outputs which can be used for a specific type of breakers. All that is explained into our manual. Depending on the power you need, we have built in some extra booster functions. This is the power boost module, and with the power boost module this allows you to generate a very powerful impulse to push the breaker in a closed position. This booster function, it's on the 24 volts, allows us to increase the electric holding current, or for a magnetic holding, increase the current to open the breaker. So these two buttons are used to increase the power for heavy breakers. We will now demonstrate the unit by connecting the session breaker, and this is a pretty heavy duty system. We're going to connect it to the BCD, open it and close it to explain the functionality in more detail. Let's continue with the demonstration of the BCD. We have a session circuit breaker and we're going to connect it to the BCD. At the back of the circuit breaker you can find the coil, and we need to connect the coil to the BCD. Make sure that the voltage, which you can read on the coil, is in line with the voltage of the BCD. So it reads 110 volts and our system is also set at 110 volts. We have connected the electrical cables here directly to the coil. In a professional environment you should do this via the connector which is mounted on the circuit breaker. So let's connect the coil of the breaker to the BCD. This circuit breaker works with electrical holding, so we should make sure that the switch is set to electrical holding. Check the voltage. Okay, we got 109 volts here, which is in line with the 110 volts requested. And let's close the breaker. Alright, the breaker is now closed, and you can see here on the display that a current of 1.1 amps is used to generate the electric holding current. Opening the breaker is exactly the same, and the breaker is opened. So the BCD is the ideal device to open and close breakers in a railway environment. Another thing we can do with the BCD is measure the manual closing time and the manual opening time of the circuit breaker. In order to do that, we need also the Balto system. What I'm going to do now, I'm going to connect the BCD to the Balto system. And what we do here, we connect this dry contact to the trip input of the Balto controller. And as soon as I push the close button, this dry contact will close and trigger the Balto controller.
So the dry contact will be connected to the trip input of the controller. In the manual mode of the Balto, we can select the manual closing time function, and when I will start the function, then the Balto will try to push a current through the breaker. I start the function, now we can close the breaker, and the time measured for manual closing is 132 milliseconds. We see now the closing reaction time of the breaker, and we see that the trip contact came in, the trigger contact came in. We see that the Balto tries to pulse a current through the main contact of the breaker, and this is how the calculation is done to measure the reaction time of the breaker.
The next thing we'll do is we will measure the manual opening time of the breaker. And of course, to do that, we need to take the other contact, the other dry contact, which will indicate the opening signal, and it will give that signal to the Balto controller.
Okay, so the dry contact stays connected to the controller. We select the manual opening time measurement. When we start the function, the current will flow through the contact of the breaker, and once the BCD will trigger the contact, the breaker will open, and we measure the time, the manual opening time of the breaker. I start the function, and we can see that the manual opening time is 364 milliseconds. When we call up the graph, we see that the trigger input came, and we can also see that the current was interrupted by the main contact of the breaker.